Hello.
Okay, good. You got it.
Okay. I'll see you shortly.
Yep.
There was for structural modeling analysis using Abacus.
I was there for systems. You can go on after the
It's 2 hours from my house, 2.5.
If it was home though.
Yeah, I would say like
I worked already.
Air Force Base, yeah.
It's like Edwards has a space.
Yeah.
And then there's a small location from like half something.
Yeah, I'm gonna be a contractor on this base. You're supposed to get mine. This week, next week. They for sure have to, no, they for sure have to match that there.
Yeah.
I mean, yeah, it's a government job. It's gonna
I calculated that.
It's a government job.
You know.
You would start off. Yeah, I was talking to Jerry. Oh yeah, yeah, it was like, well, 5 years, or like just not. Should start out at a higher pay, you only need 3 years to get to that. You got to talk to them. Did you even want to baseball? You did? Oh, yeah, I was watching one-on-one with the guy, and he seemed to want to hire him to work. So, it's kind of qualified over there. Years to get to that. That is, that's what I was thinking. Yeah, so I think, do you still have the offer or did you still start it? I would take that there with a Raytheon because that would be more at the long run. Maybe.
Yeah.
Job security.
Yeah. I was not too worried about that.
Everyone shows up money to the defense. I'd rather be yeah, but you're only 2 hours away from it.
You did 4 hours. I'll do the
Here's 2.5 hours. Oh, that's why.
Yeah.
But still, I went to school like you said. 5 hours, 3 hours. I don't really mind it, especially. Third year, you can transfer.
There's no ANSYS on these computers.
No. You don't have ANSYS workbench driving. Yeah, they're like.
You don't have ANSYS 2021 on here?
You could transfer the current department. Maybe.
Either 2020 or 2021 will work. And so at the bottom, you should have workbench 2021 R1.
I wanted to have the workforce just because it's.
Let me take a look.
Santa Barbara.
Yeah, right there. Yeah, you have to go from the start.
Around that area. Just graduate. Or.
All right, it's 7 o'clock. Let's go and get started. All right, good evening, everyone. How's everyone doing today? Today is our first ANSYS activity, and so we're very much jumping right into it. So we talked about syllabus on the first day, and then second day we're jumping right into it. So I'm doing this for a couple of reasons, because this class, part of the reason is because this class is so ANSYS oriented. So there's no better time than now than to jump right into it. But also there's a ton of ANSYS activities I have planned for this class, and so just to make sure that they're all spaced out evenly, we kind of need to start kind of right away. Okay. Kind of baby's first ANSYS, and so if you've never used ANSYS before, I'm gonna be walking through everything kind of step by step to get you acquainted. If you are familiar with ANSYS, today might be a little bit slow for you, so feel free to jump ahead in the activity if you want, or you could just kind of work on your own pace. Okay? All right, so with that said, the ANSYS, or the situation that we want to simulate in ANSYS today, is for a case where we have kind of a flat plate, so a very kind of thin plate. We have a hole in the middle of the plate, and we're going to be pulling on the plate with some kind of force or some kind of pressure on one side, and we want to see what's going to happen to the plate. Okay, and so if we kind of scroll down here, basically our goal for this activity is going to be like this. Okay. And so from our simulation results, we're going to be able to predict, what the deformation in this plate is going to be, as well as its stresses. Okay, so we have the equivalent stress and the normal stress and the principal stress. Excuse me. Okay, so that's our goal, and so we're going to go through kind of every little step here in terms of even just opening the software, how to make a geometry, how to mesh, how to apply boundary conditions, all that good stuff. Okay. And if you're curious, you might have noticed this already, but if you're on the Canvas site and you go to assignments, you'll see that I've created an assignment for this called ANSYS Activity 1, Play with the Hole. And so if you click on that, and you go to this page right here where you can download the instructions for this activity. Okay. And so if you're finding that today, if I'm going just a little bit too slow today and you want to work ahead, go ahead and download the PDF here. And then you can just kind of work through it at your own pace.
Dr. Chan, I have a question.
Sure.
So with the activities, I obviously haven't looked through the instructions, but are we so I'm just confused. Do you just want us to do the activity and not explain anything? You just want pictures and our FEA model,
Yeah, so the PDF will explain. So there will be times where I want kind of screenshots of your results.
yeah,
I want to have
what are you
screenshots of
gonna want from us?
Yeah, so as you go through the instructions, it'll kind of explain kind of what I want.
Oh, I see.
Yeah,
Okay,
so a lot of times it's basically a screenshot from ANSYS, as well as some kind of explanation of kind of, what you're looking at in that.
Is there a certain page limit, and are we allowed to use references and provide sources?
Yeah, you're allowed to use sources. There's no page limit. However much you need to get the point across.
Sounds good. So these activities have clear instructions on what is expected of us to turn in.
Exactly. Yes. Yeah. So it should be very clear. So the way these activities are kind of designed is that the first part is mostly going to be just instructions. And so for this activity, the instructions are pretty detailed because it's your first time using ANSYS. But if you kind of scroll to the bottom, there are a lot of problems. And so for these problems here, it'll tell you kind of to do this, make this change in the simulation, and then show me a screenshot of this. And answer
Nice. Okay. As long as everything is clear, I don't think I'll have an issue. Thank you, sir.
Yep, no problem. Yeah, so if you want to kind of move forward in the activity and kind of go to those questions and kind of skip through that, you're definitely more than welcome to do so. I know some people are coming in with varying levels of ANSYS experience. But I know for those of you that are coming in kind of fresh, I want to do this activity kind of, detailed just so that, we're all kind of on the same page by the end of the day. Okay. And so, usually with these activities, I design them so that you can finish a decent chunk of them within the course or within the lecture. But sometimes you might have to take these home or kind of work on them on another day. So, if you look at the due date here, this activity is going to be due next Friday by 11:59. Okay. And so that's the deadline to kind of finish everything in the activity and to submit the PDF. Okay.
And Dr. Chan,
Yeah.
I'm sorry to interrupt, but I just have these questions. Might as well get them out there on the first day. So is each assignment going to be graded? Like, is each assignment worth 20 points, or are the points different for each assignment? Are some assignments worth more points?
All the assignments are worth the same amount of points. I have 8 of them planned, and so they're all going to be worth 100 points each.
Okay, and then so those questions that I was referring to earlier, are they all equal points, or are some questions worth more points than others?
They're all roughly equal.
Okay, thank you, sir.
Okay. All right, any other questions I can answer before we begin today? Okay, all right, so let's go and get started. So if you have the PDF open, that's great. But we're going to start with kind of the simplest thing, just starting up the software, because it's not actually clear. Question? Yes.
So the way these assignments are set up, are they going to be due at the end of the class period?
No, they're not. So there's nothing due at the end of the class period. So all of it's going to be due by next Friday. Yeah. So basically finish as much as you can in the class, and then just whatever you don't finish is going to be, the rest is going to be homework. Yeah. Okay, so let's start by starting up the software because it's not immediately clear. And so if you're on a Windows machine, you can go ahead and click on the Start menu. And then under your applications here, under A, you should see a folder for ANSYS. If you're on the school computers here, you should see 2 folders for some weird reason, but we want the latest version, the latest one that we have, which is ANSYS 2021. And so you're going to click on the down arrow for ANSYS 2021. And what you should see is actually a ton of different programs. And the reason for this is that ANSYS is actually a collection of a lot of different programs all working together. And so if you were kind of an expert and you kind of knew exactly which software you wanted, you can kind of jump ahead and click on that software that you want. But for most people, what they want to open is actually what's called Workbench. Okay? And so this Workbench program within ANSYS, that's kind of almost like the master program. And that's going to open up all the other programs from there as you move. Okay. And so to launch ANSYS, the best way to do that is to launch Workbench. And so if you're kind of following along, go ahead and click on Workbench 2021 R1. If you downloaded ANSYS Student using the instructions that I have yesterday, you probably have the 2023 version. And so you're going to click on Workbench 2023 R1. Okay, so let's go ahead and click that. If a security alert comes up, just say cancel. Unless you're on your personal computer, then feel free to give ANSYS all of your personal information, social security number, and all that good stuff. All right, and so if ANSYS launched correctly, It might ask you to do this improvement program, say no. Yes, if you're nice, being nice to ANSYS, okay. And then what you should have is this kind of this empty space right here, okay. And so from here, you know, you can kind of do a lot of stuff, okay. But the first thing we need to do is we need to specify the type of analysis that we want to do, okay. And so the thing about FEA and the thing about ANSYS, the thing that ANSYS does really well is that you can actually perform a lot of different types of analysis within ANSYS. And so if you kind of look kind of on this left menu here for all the different types of analysis systems, you can see there's a lot. And so you can see things like explicit dynamics, you can see things like electric. We have all different kinds of fluid flow tools. You can do some kind of vibration analysis, you can do thermal analysis. Okay? And so I like looking at this because it kind of shows kind of the breadth and it kind of shows the capabilities of FEA. Because I think for generally most people, when they think of FEA, they think of just the structural side. But FEA is kind of a lot more than that. You can solve a lot of different types of systems. Okay? But for our case, you know, we're going to start out with kind of one of the more simplest cases, and that's going to be a structural simulation that does not change with time. Question? You don't have anything here at all. Is the toolbox just missing just completely? Okay, so if you go to view, you may have to check on this this button right here. So click on view and then the tool and then click on toolbox from there.
Just says no toolbox.
Okay, I'll come back and check on you. Yeah. Okay, so for the rest of you, let's go ahead and create a static structural object here. Okay, and so you can do that a couple ways. So you can double click on static structural, or what you can do is you can click and drag this into the area. Okay, so I like to click and drag, or you can double click, whichever is more familiar to you. Okay, and so whether you double click or you click and drag static structural, you should have this menu here. Okay. And before we start, we need to make kind of one important change because the analysis that we're doing, if you go back to the problem specifications, is actually a 2D analysis. And so we don't need the third dimension. So we want to make sure ANSYS knows that we want to do a 2D analysis. And so to do that, you're going to right click on engineering data. Okay. You're going to click on this button here called properties. And so when you click on properties, it's going to open up something on the right-hand side where you can change a lot of settings for your simulation. Okay. Okay. All right. So after the properties window comes up, what you're going to do is you're going to left click on geometry. And so basically you're looking at the properties for the geometry part of your analysis. And then you're going to come to this area right here for analysis type. And if you look at the default setting for analysis type, you can see that it's set to 3D. And then what we want to do is we want to change it to 2D because we want to do a 2D analysis. Okay. So let's go ahead and change that. And so let's change the analysis type to 2D so that we're ready to kind of move forward from here. Okay. Any questions on this so far? So far, all we've done is just we've opened up the software, we've created a static structural analysis, and we've changed the analysis type to 2D. Okay. All right, so I'll kind of make my rounds just kind of quickly in a second, but the next thing that we're going to do is we're going to start constructing the geometry. Okay. So normally you don't have to do this for most cases because a lot of times you're going to be importing the geometry from another file. But for this activity, because the geometry is so simple, we're going to go ahead and construct it within the software itself. Okay. Let's go ahead and right click on geometry. And you're going to click on this entry right here called new design modeler geometry. Okay. And so when you do that, it's going to open up a new program called design modeler, which is one of the built-in CAD softwares within ANSYS. And then you can use that to kind of construct the geometry. Okay. So let me click on this, open up design modeler, and then let me go ahead and catch. I know some people are having some issues right now. Okay. But go ahead and open up design modeler, and then just if you want to kind of move on, you can read the PDF, but I'll come back and kind of go through it with you guys. Yeah, it's just legs. Great. Oh, yeah. Okay, yeah, I think this is just right. It doesn't really, we're not gonna spend much time, so. Yeah, sometimes it's tougher for you. You were able to change it to. Yes. Okay. So I was just- Okay, just give it some time. Oh, that's that's kind of. That one's just not. Oh, so this is the. Yeah, I kind of skipped. Want to make sure we get. Yeah, we. Guys, are good? Guys all good? Okay. All right, everyone on Zoom, okay? Anyone running into issues on Zoom?
I'm doing fine, sir.
Okay, good. Okay, and so I know some computers are being a little bit laggy, so hopefully they catch up a bit soon. But let's go ahead and make the geometry, okay? And so our goal in this part here is to basically make a computer model representation of our geometry, okay? And so our geometry in this case is pretty simple. So it's just a plate with a hole, okay? So we basically want to make a rectangular plate. We have the dimensions of the plate. The dimensions of the plate are given in the PDF. And so we want to make that in ANSYS, or in design model, I should say. Okay, so the first thing we want to do is we want to make a sketch. And so to make a sketch, let's go ahead and zoom in on the XY plane. Okay. So there's a couple ways that you can do this. And so the way that I usually do it is actually a little bit different from the PDF, just because the zoom bar is kind of blocking me a little bit. Is I like to just click on this Z arrow right here. Okay? And so when you click on the Z arrow in the bottom right of the screen, so let me use my pen here. Okay. And so when you click on this arrow down here, what that does is that it changes the perspective so that you're looking kind of straight on from that axis. Okay. And so let's click on this Z here. And you can see now that we're kind of looking right at the XY plane. Okay. Okay, so let me go ahead and clear that. All right, so now that we are zoomed in on the XY plane, okay, we're just about ready to start sketching. But before we do that, one more thing that we should change, which I just remembered, is we should change the units. Okay, and so on the upper bar of the screen, you should see a setting called units. Okay, and so what this will allow you to do is that this will allow you to change, what type of units that you can dimension the geometry. Okay, because right now our dimensions are in meters, and so if you look at kind of the ruler on the bottom, everything is measured here in meters, okay? Which is okay, but it's going to be just a little bit more convenient for us to work in millimeters instead. So let's go ahead and change the units.
Dr. Chan.
Yep.
Does that imply that we're going to be working only in SI units throughout this course?
Mostly yes, but I think there are a couple of times where we work in English units as well.
Do the homework state clearly if you're expecting SI units or English units?
For the activities, they're not as important. I'd say you can probably work in the units that you feel most comfortable with.
Sounds good.
But you should still reproduce the same results that I'm looking at.
Sounds good.
Whichever units you use is not that important to me. Yeah,
Okay.
question. Oh yeah. Oh, yeah. So you click on tool or you click on view and you click on toolbox right here. Yeah. Let's go ahead and change our units. So let's change it to millimeters just because it'll make it just a little bit more convenient. Okay. Let's start sketching. And so to start sketching, you're going to go to this part of the screen right here. Let me go ahead and clear my drawings. Okay. And you're going to click on this tab right here called sketching. Okay. And so what that's going to do is that it's going to change the controls to sketching tools. Okay. And you can see here that we have quite a few kind of rudimentary shapes available to us to start our sketch. Okay. Okay, so from here, you can construct the geometry in whichever order that you want. For me, I like to start with just kind of the outer rectangle. So let's click on rectangle here. Okay. From here, to make a rectangle, all you have to do is kind of click on one point of the geometry or click on one point of the screen, and that's going to start your draw. And then you can see here that as you move the mouse, it's going to make the rectangle kind of bigger and small. Okay. For now, we're going to dimension this rectangle so that it has the proper dimensions. So you can kind of draw the rectangle as big or as small as you want. But it would be kind of the most convenient if you kind of make sure the rectangle kind of is centered roughly around the origin. Okay. Okay. And so we've gone ahead and drawn our rectangle just like that. Okay. Any questions on this so far? Is everyone able to draw the rectangle? All right. So now that we've drawn the rectangle, the next step is to dimension it. Okay. And so by dimension, what I mean is that we're going to define the size of this rectangle. So we're going to define its length, and so we're going to define its horizontal length as well as its vertical width. Okay. And so to dimension a drawing here, you're going to click on dimensions here on the left-hand side of the screen. When you click on dimensions, you can see that there's quite a few dimensioning tools available to you. To start out with, we're going to start out with the general dimensioning tool. And so what this allows us to do is that it allows us to set the length of certain edges or certain lines within our drawing. Okay. So let's start with the general dimension tool. It should be clicked by default, but if it's not clicked, go ahead and click it. And what you're going to do is you're going to click on one of the horizontal edges of your rectangle. Okay. And so by doing that, it's going to draw out a dimension like this. Okay. If you're used to SolidWorks, this is going to be very strange because I know in SolidWorks, what it allows you to do is it allows you to define the dimension right here. But ANSYS does it a little bit differently. Some people like it, I personally don't, but but the way it basically sets the dimension is that you can see that it defined this dimension as H1. And if you go to the bottom left-hand side of the screen, you can see the actual length for H1 right there. Okay. And so to change it, you're going to go to the bottom left-hand side of the screen and you're going to change it to the appropriate dimension. Okay. Check back on our PDF. We can see that the length of our plate here is 300 millimeters. Okay. So let's go ahead and change this H1 here. So the one I drew is about 94.2. Yours is going to be different because everyone's mouse is a little bit different. But let's go ahead and change this to 300. What that's going to do is that it's going to make probably going to make your rectangle a lot bigger than what it was before. All right, so let's go ahead and do the same thing, but we're going to set the vertical width of the rectangle now. Okay, and so we're going to click on general dimension. We're going to click on the vertical edge of the rectangle, kind of bring it out. We can see that it's ANSYS gave it the name V2. Okay, we're going to do the same thing. We're going to go to the bottom left-hand side of the screen. We can see that V2 right now is 62.09 millimeters, and we're going to change that to 200 millimeters. Okay, and so after you dimension it, your rectangle should have a length of 300 millimeters and a width of 200 millimeters. Any questions on this so far? Everyone doing okay? Everyone's able to dimension it? All right, let me finish dimensioning the rectangle part, and then I'll kind of go around just to check how everyone's doing. All right, so the next thing we want to do is, our rectangle is the appropriate size, but it's going to be pretty convenient. It's going to be more convenient for us if our rectangle is centered directly on the origin. Because right now it's not. And oh, if you want to pan, if you want to kind of move this kind of display here, kind of within the plane here, the way that you do that is you hold control on the keyboard. And so I like to hold control with my left hand. And then you click on the middle mouse button, so your mouse wheel, and you kind of click and drag that around, and you can pan around that. Okay. All right, so let's go ahead and center this rectangle on the origin. And so the way that we can do that is we're going to use the different dimensioning tools within Design Modeler. Okay. And so the first one we're going to use is we're going to center it in the left-right direction. And so we're going to click on horizontal dimension here. So click on horizontal dimension. And what the horizontal dimension allows us to do is it allows us to specify a distance between two entities in the horizontal direction. Okay. And so in this case, we're going to set the horizontal distance between the left edge of the rectangle and the y-axis of the coordinate system. Okay. And so you're going to click on those two things with the horizontal dimension highlighted. And that should create a new dimension here called H3. Okay. And so if you go to the bottom left-hand side of the screen, you can see here that H3 right now for me is about 42.73. Okay. And so we want to change this so that it's about half the distance of or half the length of the rectangle. Okay, so half of 300 is about 150. And so let's go ahead and set that to 150. So now the rectangle is centered kind of, in the X direction. All right, so I'm going to repeat the same thing with the vertical dimension. And so with the vertical dimension, we're going to set the distance between the x-axis, bottom edge of the rectangle. If I can zoom in. There we go. Okay. So that's going to create another dimension V4. And so let's go ahead and set this to 75, which is half of, or excuse me, we should set this to 100, which is half of 200. Okay. And so with that, you should have a rectangle that's kind of nice and centered around the origin of the coordinate system. Any questions on this so far? You guys need me to come around? Anyone, everyone's doing okay? Okay. All right, so let's just finish this out then. Let's go ahead and finish up creating the rectangle with the hole, and then I'll probably make my rounds after that to make sure everyone's doing okay. Okay, so the last thing that we're going to draw here is we need to draw the hole. Okay, so the hole is kind of the last part of the geometry that we need. So let's go back to the drawing tool. So let's click on draw right here. And then what we want to do is we want to draw a circle, and that circle is going to represent our hole. Okay. And so this is the reason why, I kind of went through the trouble of centering the rectangle on the origin, because now we can draw the circle and we can have it centered right on the origin, and it's going to be right in its proper place. Okay. So go ahead and click on the circle drawing tool, click on the origin, and then you're able to draw your circle kind of as big or as small as you want. Okay. I'm just going to set the circle to be that size for now. Okay. All right, so the next thing we're going to do is we're going to dimension this circle. So we're going to basically define how big the circle is. Okay. And so if we go back to the PDF, we can see here that the hole diameter is 50 millimeters. Okay. So with the general dimension tool, if you click on just one of the edges of this circle, see that we can define the diameter of the circle as D5. Okay. And so same thing we did for all the other dimensions, we can set its value in the bottom left-hand side of the screen. And so let's set it equal to 50. Okay. Okay, and so that's it for the drawing. And so, by the end of this, you should have 5 dimensions. And so you should have 2 dimensions for the absolute length, the absolute width of the rectangle. You should have 2 dimensions that positions the rectangle right on the origin of the coordinate system. You should have 1 dimension for the circle. Okay? So 5 dimensions, 2 shapes. All right, any questions on this so far? Yep.
So can we nomenclature EGME D5?
I think you can. You mean change the names of the dimensions?
Yeah.
You should, I think you should be able to. Let's see. I'm not sure exactly where you can change it, but I'm pretty sure that you can. It's just kind of been a while since I've done. Mhm. I'll look into it after the class. Okay, all right. So one last thing that we need to do here before we leave is that we need to make sure that we can actually make a surface out of this. Okay, because all we've done is just we've made a sketch, and so we basically need to make sure that the program knows that we're actually making a geometry here. Okay, so let me go ahead and clear my annotations here. Okay, so you're going to go back to the modeling tab here. Okay. And if you did everything correctly, the XY plane should have a plus arrow next to it, and that should have a sketch 1. And so sketch 1 is the one that we just created. Okay. All right, so what we want ANSYS to do from here is we want to actually turn this into a surface that we can run simulations on. Okay, so let's go ahead and click on concept here. Concept is on the very top of the screen, kind of near the top left. And what we want to do is we want to click on the tool for concept from or surface from sketches. Okay. Okay. And so after you click on surfaces from sketches, what that's going to do is that it's going to create a new tool right here. Okay. And so you should have something called surface SK1. And more importantly, it's gonna change the bottom left-hand side of the screen here in the details window. Okay. All right, so what we want to do basically is we want to tell ANSYS to basically take our sketch 1 and turn it into a surface. Okay, and so we're going to click on sketch 1 here. Okay. We're going to make sure sketch 1 is highlighted in blue. We're going to click on apply. Okay, and so apply is here in the bottom left-hand side of the screen in the details window. Okay, so with sketch 1 highlighted, you want to click apply. Question?
Do you click control and take every line?
No, you don't have to. So you can just click on the sketch right here, and it should highlight every single line there. It should be fine, yes. Yeah. Okay. And then so once you have that applied, the last thing we need to set here is the thickness of the plate. Okay. And so basically, the way that you can think of this is that ANSYS is going to take the sketch and it's going to extrude it in the direction that's perpendicular to the screen. And so we need to tell it, how much we're going to extrude it by. And so we go back to the PDF. You can see that the thickness of the plate is about 5 millimeters. Okay. All right, so let's go ahead and set this to 5 millimeters. Okay. And so that's going to tell ANSYS to extrude by 5. Okay. And the last thing we need to do before we leave here is to click on this button right here called generate. Okay. All right, so in general, and so this has kind of been true for ANSYS in general. Whenever you kind of see a lightning bolt next to an object, that means that ANSYS is we've kind of set the settings in ANSYS, but we haven't yet, actually created, or we haven't actually run the simulation. Okay. And so let's go ahead and click generate. And so after you click generate, you should see your surface or your geometry kind of form in this way. Okay. All right. And so before people ask, I know people are going to ask this. And so if you go to the PDF, I know the geometry that I have here looks like it has a bigger hole. Okay. And the reason for that is because I changed the dimensions for this activity, but I didn't change the screenshots. And so the screenshots are going to show a bigger hole, but that's okay. And so the hole that you have should be kind of around this size. So it's kind of a fairly small hole compared to the screenshots in the activity. Okay. All right, so any questions on this? Was everyone able to get this plate with the hole as it is right here? Okay. Yeah.
Is there any reason to use the surface in concept rather than extrude that?
Yeah, so actually, even though I said that we're kind of extruding it, we're not really extruding because we're running a 2D simulation. And so if you actually use the extrude button, that's actually going to make a three-dimensional object. And so if you kind of rotate around here, you can see that it's still really thin. And so even though we added a thickness to it, it's kind of more like it's like a fake thickness. Yeah. Mhm. Yeah. Yes. And so 2D simulate, I made this activity 2D just so it's a lot easier to run. It's a lot easier to mesh. We'll start doing 3D in the next activity. Yeah. Mhm. All right. Any final questions on this before we move on? Everyone on Zoom doing okay?
I'm going good.
Okay, all right, cool. All right, so we're actually all done with design modeler, so you can actually close it. But be careful, you don't close Workbench. You only want to close design modeler, okay? Because if you look down at your Windows toolbar here, you should have two programs open. So you should have Workbench open and you should have design modeler. So you only want to close design modeler. And so what that's going to do is that it's going to load the geometry into ANSYS, okay?
Do I need to save?
No, you don't. And so you can just close it. So everything is saved through Workbench. And so you can just close it from design model. Yeah, good question. Okay, and so the next thing we want to do is we want to open up the next program in ANSYS, which is called ANSYS Mechanical. So Mechanical is actually where we're going to be running. We're actually going to be running the simulation. Okay. So to open up ANSYS Mechanical, if you kind of go back to Workbench here, you should see that our static structural tree has updated a little bit. Okay. And so now that the geometry is set, there should be a green check mark next to geometry. If you kind of remember what it looked like before, there was kind of a blue question mark there because we hadn't specified it yet. But now that we've specified the geometry, it should be a green check mark. And so the next step in the process is the step called model. Okay. And so what we're going to do is we're going to double click on model here. And what that's going to do is going to open up a program called Mechanical. And so Mechanical takes a while to load. And so I know some computers in the lab here are running a bit slow. But the way you can kind of check is that after you click on model, in the bottom left of the screen, you should see a little tooltip that says starting Mechanical. Okay. So depending on your computer, it may take a while. So we'll kind of give it a few minutes. Okay. But eventually another window should pop up called ANSYS Mechanical, and it should have your geometry kind of attached to it. But, if it's your first time, opening ANSYS Mechanical on your computer, if you're on the lab, this ad might pop up. Okay, but it should be in a window called ANSYS Mechanical, just like that, or a static structural mechanical. If you're in this window right now and you're getting the following kind of window here, so this is just an ad, so it's just asking if you want to watch a YouTube video. You can do that if you want, but we're not interested in it right now. And so to kind of make it go away, you can kind of click on anything in this part of the window right here. Okay. And so let's go ahead and click on geometry. So if you're in ANSYS Mechanical and you click on geometry, you should be able to see your plate with the hole if it transferred over correctly. Okay. Any questions on this? Was everyone able to load their geometry into ANSYS Mechanical? Okay. Okay. All right. So now we're in Mechanical. So now we are going to be rolling. Okay. All right. So the first thing we're going to do is we're going to create a mesh. Okay. And so remember what we talked about on Monday. A mesh is basically a way to break up our geometry into a bunch of simpler shapes. Okay. Another way that you can think about this is that we're basically pixelating our geometry. Right? Because right now what we have is kind of a solid geometry here. Okay? But this geometry isn't suitable right now for finite element analysis. And so we need to break this up into simpler shapes so that we can actually conduct our analysis. Okay? All right. And so, usually what I like to do, this is not in the handout, this is not in the PDF. But usually what I like to do when I'm starting a new analysis is I like to just generate a mesh without setting any settings, okay? And so what this will do is that this will tell me kind of right away if ANSYS is able to generate a mesh on the geometry, because that's not necessarily the case all the time, okay? And this will kind of give us a good starting point for, how we can modify our mesh, okay? And so to generate a mesh, you can right click on mesh, and then you're going to click on generate mesh, okay? And so it should mesh fairly quickly because it's a 2D geometry, okay? And you should get a mesh that maybe looks something like this, okay? All right. So was everyone able to get a mesh on their geometry? Okay. All right. So this mesh is okay, right? It's not the prettiest looking mesh, but it's not the ugliest either. Okay. One thing that you can check for your mesh, and this is not in the PDF either. I should really update it. Is a lot of times when you make a mesh, you're interested in how many elements and how many nodes are in the mesh. Okay. Because a lot of times the amount of elements that's in your mesh, that's an indicator for how expensive or how time consuming your simulation is going to be. Okay. Oh, thank you. Okay. All right. So to check the number of elements in your mesh, you're going to left click on mesh here in the project outline, and then you're going to go to the bottom left hand side of the screen, and you're going to click on statistics. Okay. And so if you click on statistics, you click on the plus arrow next to statistics. This will tell you how many elements and how many nodes are in the mesh. Okay. And so for your meshes might be a little bit different because there's a little bit of randomness associated with meshing, but you should have around 100 elements in your mesh, and the amount of nodes you should be somewhere between 300 and 400, depending on your mesh. Okay. Question.
By elements is like how many rectangles or shapes it's broken into.
Exactly.
And the nodes is like the meeting points.
Exactly, right. Yeah, so the elements are basically all the shapes. And so this is one element right here, okay? So what these statistics are telling us is that there's about 100 of these guys in the mesh, okay? And all the nodes, those are referring to basically any of these vertices right here, okay? So, if you really want, you can verify this, and so you can go and sit and count how many elements you have in there, but it's accurate, so you don't have to do that. Okay. Okay. So this mesh is okay. It's not bad, and actually, I think for the simulation that we want to run, this should actually get us some decent results. But that's not always the case. So that's not always the case for the simulations we want. So let's refine this mesh. Okay, so the first thing, it just by gut instinct, I look at this mesh. It looks fairly coarse, and so the first thing I would say is that we can add some more elements to this. We can make the elements smaller so that we can get a more accurate result. Okay. All right, so let's do that first. So I'm going to show you how to modify the size of the elements. And so you're going to right click on mesh. You're going to go to insert, and then you're going to click on this setting here called sizing. Okay. All right, and so if you read the tooltip for sizing, you can see that it says it controls the size-related settings such as element size, the number of divisions along the edge, use the sphere of influence, minimum size, all that stuff. Okay. But most importantly, it's going to allow us to kind of change, how big or how small our elements are going to be. All right, so let's go ahead and click on sizing. Okay. Expand this out just a little bit. Okay. So after you click on sizing, you can see that we've created kind of a new sub element in our project tree here. Okay. So that sizing element is going to allow us to basically set the size here. Okay. So there's a couple of things we need to set. And so the first thing we need to set is we need to set the geometry. Okay. And so what that means is that we need to select the part of our geometry here where we want to specify the size. Okay. So the nice thing about this is that we can specify different mesh sizes in different parts of our geometry. That's going to be very relevant in the future. But for right now, we kind of just have one area. So we just want to kind of select the entire thing. Okay. And so what you're going to do is you're going to click on basically anywhere on the plate that's not the hole. Okay. And then you're going to go to geometry here. You're going to click apply. Right. So if you do that correctly, you should see the geometry is set as one face. So that's the first thing that we need to set. The other thing we need to set here is going to be the element size itself. Okay. And so you can see the default size here is about 3 times 10 to the minus 2 meters. Okay. We can go ahead and change our units to make that a little bit more convenient. And so if you go to the home part of ANSYS Mechanical here, okay, there is a setting here called units. Okay? It's in a slightly different location than in Design Modeler because of convenience and designers not talking to each other. Okay, and so just like we did in Design Model, let's go ahead and change the units here. Okay, and you can see here we have a lot more options, but just for the sake of consistency, I'm going to change the units to something with millimeters. So that's going to be the third entry here. Okay. So that's going to make it a little bit more convenient to change the size of these elements. And so now we can see the size is about 30 millimeters. So let's go ahead and change this down to, let's cut the size in half. So let's make the size 15 millimeters. And let's see what happens. And so let's go ahead and update our mesh. And so anytime you make any changes to the mesh settings, you have to actually manually update it. And so, now that the size is set to 15 millimeters, let's go ahead and click update. And you can see here that our mesh has been updated. It's changed, right? And so now our mesh has slightly smaller elements. And so this actually looks a little bit cleaner. Okay? And play around with the sizing a bit. And so you can change it to kind of anything that you want. But for this activity, I'm going to take it down to 5 millimeters. Okay. So let me go ahead and update the mesh. So that gives us a mesh that looks something like this. Right. So let's go ahead and check the statistics here. And you can see now that we have a lot more elements and nodes in our mesh. Okay, so we went from about 100 elements. Now we have about 2,300 elements. And we went from about 350 nodes to 7,125. So pretty significant increase.
So Dr.
Question?
John,
Yes.
I can go afterwards if someone has a question, inside the class.
No, you're good.
Okay, I thought I interrupted someone. So I noticed that you obviously increased the number of meshes. And I'm familiar with increasing the number of meshes increases the computational cost for the software. However, does that matter because we're working in a 2-dimensional geometry? It's still feasible with this many nodes.
Oh yeah. So because we're in 2D, most unless you crank this up to like 1 million elements, the cost is going to be very modest. And so you can crank this up for as much, almost as much as you want. And so
sounds good.
Yeah, but this is, I will admit, this is a little bit overkill for kind of the results that we're looking at. But I kind of wanted to illustrate to you that, the mesh, depending on the size that you choose, is going to make a dramatic difference in what it looks like. And over the next couple of weeks, we'll talk about, what this relationship is between element size and accuracy and element size and cost. And so.
Yes, I'm very interested. Thank you, sir.
Yep. All right, and so I know in the PDF that it goes through a couple other mesh settings, but just for the sake of time, I'm just going to kind of leave it at the sizing. The sizing is probably the most important setting for the mesh that will cover at least for the immediate future, and for the other stuff, we'll kind of cover that in kind of due time. But for now, let's just focus on the size. Okay. Any questions on this so far? All right, and so that's the mesh, and so I'd say this mesh looks really good right now. Okay. So the next thing we need to specify here is the boundary conditions. Okay. All right, so let's go back to the PDF. So the boundary conditions basically represent any kind of external effects that are being applied to the plate. Okay. In this case, we have 2 boundary conditions. And so we have a boundary condition on the left side of the plate, and we have a boundary condition on the right side of the plate. Okay. And so on the left-hand side right here, basically what's happening is that this plate is being fixed to the wall. So it's basically bolted or welded or something to the wall. Okay. And so one way that we can say this is that this end of the plate is fixed. On the other side of the plate, we're applying some kind of external force to the plate. So what we can say is that this is a load that we're applying to the plate. Okay. And so this tells us that we need to apply 2 boundary conditions onto our simulation in order to emulate these exact conditions. Okay. Okay. And so that means we're going to apply two boundary conditions here to emulate that. Okay. All right. So let's to apply boundary conditions, you're going to right click on static structural A5. Okay. And then you're going to go to the setting, or you're going to go to insert. Okay. And then from this menu, you can see there's a lot of different types of boundary conditions that we can apply. Okay. And so there's kind of too many here, even too many here that we can't go over all of them, in the whole class. Although we will kind of visit quite a few of these. Okay. And so the first one I want to set is called the fixed support. Okay. So what the fixed support boundary condition specifies is that it allows us to kind of identify a part of our geometry that is going to remain fixed. Okay. And what fixed means is that the deformation of that part is going to be 0. Okay. So let's click on fixed support. And then now it's going to ask us to select what part of the geometry is going to be fixed. Okay. And so if you remember from the PDF, the part of the geometry that's fixed is going to be this left-hand side edge right here. Okay. And so what we want to do, and you kind of need to be careful here, you want to select just the left edge of the geometry. Okay. And so if you click on the edge, the only thing it should highlight is just that edge in green. Okay. And you kind of click it again just so you can see. Okay. So making sure that you're only selecting that left edge, go ahead and click apply. Okay. What that's done is that it's selected that left edge as your fixed support. Okay. Okay, so the other boundary condition that we're going to specify is a mode. Okay. And if we go back to the PDF. Question, yes.
On your software, it says that geometry is one edge, when mine it says one face.
Yeah, so if it says one face, then that means you accidentally click the entire face. And so to kind of make sure that you click an edge, you can change the select mode. So you can change the select mode here. Okay. So you should see kind of a cube kind of above the thing. Okay. And so with that one selected, let me go and close this. That's called edge selector mode. And so that basically forces it to click on an edge. Okay. So if you're having trouble just selecting the edge by itself, you can basically force ANSYS to select just an edge, just like that. Okay. Yep. Mm-hmm. Okay, so let's go ahead and add our mode here. All right, so our mode in this case, if we go back to the PDF, our mode P, it's actually given in units of pressure. So if you look at our mode here, it's 1,000 megapascal or 10,000 megapascal. Okay. So let's go ahead and insert a pressure. So let's go ahead and right click static structural A5, go to insert. And this time we're going to go up to pressure. Okay. Let's go ahead and click on pressure. And this time you're going to click on the right edge of the geometry. Okay. Go ahead and hit apply. Make sure it says one edge right here. Okay. And the magnitude for this is going to be 10,000 megapascal. Okay. All right, so we have our two boundary conditions, and so we have our fixed support, we have our pressure. Okay. On this so far? All right, so we're almost done. So the last thing we need to specify here is our output variables. And so we have our mesh, we have our boundary conditions. Technically, we have everything we need to solve. But then after we solve the simulation, we need to tell ANSYS which quantities that we want to look for. Okay. Question?
How do you find the direction of pressure?
Oh, good question. So the direction of the pressure by default is going to be away from the surface. But if you want to select the actual direction, you can define instead of normal to. You can click on vector right here. And so vector here, you can specify the, you can select components. And from there, you can select the X and Y components of the force. Okay. All right, so now that we have the boundary conditions set, the last thing we need to specify is the types of outputs that we want ANSYS to produce for us, okay? All right, because, when you run a simulation, there's lots of different quantities and there's lots of different, fields that you can have ANSYS view, for you to see. Okay, so to set this type of outputs that you want to see, you're going to right click on solution A6. You're going to go to insert. And you're going to go to, you can see there's all types of outputs that you can see. Okay. So for this activity, we're just going to look at kind of the basic, I would consider kind of the basics of a structural simulation. And so the first thing we want to see is the total deformation. So let's click on total deformation there. And let's look at just one of the stresses for now. So let's look at just the equivalent stress. Okay. And so you're going to right click on solution A6, go to insert. Go to stress, and then go to equivalent von Mises. Okay. I think in the PDF, it asks you to look for the principal stresses as well, but we'll just kind of ignore that for now. Okay. So you should have two outputs here. So the total deformation and the equivalent stress. So the last thing that you need to do is you need to just click solve. Okay. So once you have all these things, you can double check one more time, make sure your mesh looks okay. Make sure that you have your boundary conditions. And when all of that is done, there is a big button here with a lightning bolt that says solve. Okay.
I have a question, Dr. Chan.
Yeah.
So you just highlighted all the steps basically to make an FEA simulation. I'm wondering going step is usually the most hardest.
Yeah, no, that's a good question. So, for a more complicated case, you're going to be spending a lot of time on the meshing,
Okay.
just because for complicated geometries, making sure the mesh has sufficient number of elements, and has sufficient quality. So we'll talk about mesh quality, I think probably starting next week too. It can be very tricky.
So we should expect to be spending a considerable amount of time doing the mesh.
Sometimes. And so, for complicated geometries, the mesh is definitely the part.
I see. It does depend on the case.
Right. But sometimes also the loading and the boundary conditions can be tricky as well.
I see.
And actually, besides those, I think probably people spend the most time with just kind of iterating on this whole process. And so
Nice.
a lot of times though, you'll run a simulation, you look at the results, you'll think, that doesn't look quite right. And then you kind of
Optimizing
settings until it looks right.
Someone posted a question
Yes.
in the chat.
Yes. All right. So question in the chat, do we need to pick a material property for this? Normally you do, but for this activity, we're just using the default material. So if you don't select a material property, it defaults to a material called structural steel. And so that's fine for this. Question. Okay, same question. Okay. Okay, all right. And so now that we've hit solve, you can click and view on the different results. And so you can click on total deformation. And so from here, you can see how much the plate is deforming. And so if you look at the color bar here, you can see the maximum deformation is about 16.85 millimeters. And that's occurring in the red region. So everything in the red is deforming by about 16.85. Okay. And then the different colors represent different values of deformation. So the orange looks like it's around between 14.9 and 13.1. And then there's kind of a steady gradient all the way down to 0. Okay. Notice that we do have a 0 deformation, and the reason for that is because we have a fixed support on the left-hand side. Okay. All right, so let's look at the stresses. And so this tells us a measure of how much structural stress the plate is undergoing. Okay. You can see here that we have a maximum stress of about 33,000 megapascals. Okay. And you can see the region where it's occurring. So it looks like the maximum stress is occurring kind of on the top and bottom of the holes, kind of right here. Okay. All right, and so that's about it. And so that's kind of ANSYS in a nutshell. So basically, we went through the whole process. So we went through making the geometry. We meshed our geometry. We applied our boundary conditions. We defined outputs, and we solved. And so question? Yes.
Can you show us how to save?
Yes. Yeah, that's the next step for sure.
Thank you.
Yeah. Question? Yeah.
Can you edit the actual graph?
What do you mean edit the graph?
Like in terms of like, I wanna take away the.
Oh, yeah. You can edit the display for sure. So yeah, that's a good question. And so a lot of times, you want to view the results. You don't want it to display kind of the mesh grid lines here. And so the way that you change that is that you go to results here. Okay. It's a result here in the top right, in the top left. Okay. And then you're going to click on edges here. And then there is a setting here called no wireframe. And so what that's going to do is that it's going to show the results without the grid. And so if you just wanted to see just the heat map just by itself, that's how you do it. Yeah. All right. And so that's ANSYS in a nutshell. And so I'm going to show you so saving is will be the last thing I show you today. But before I do that, let me talk about the rest of the activity. Okay. And so we basically kind of went through the whole tutorial here. So that's going to be most of this activity. And so what I want you guys to do for the rest of the activity is to first of all interpret it. Okay. And so I want you to talk about, what's the maximum deflection or what's the maximum deformation in the plate? Where does it occur? I want you to answer, what's the maximum stress in the plate? Where does it occur? Okay. In addition to this, I want you to show me screenshots of your deformation equivalent stress. Okay. Problem 2 of this assignment is to iterate on this. And so I want you to play with the settings and see how that changes the results. Okay. And so I want you to change the loading. Okay. See, change the loading to about 2,500 megapascal. Okay. And then see how that changes the results. I want you to try changing the hole, change the mesh size, change it to triangular elements. Okay. Part E, you don't have to worry about. We didn't talk about refinement today, and so you don't have to do part E. Okay, but I do want you to do up to part D of the problem 2. Yeah.
I have a question, sir.
Yeah, go ahead, Ivan.
So part E, are we expected to not do that at all?
No, you're not. No.
Okay, so that's not included in the submission.
It's not included in the submission, correct?
Also, for the sections that we need to provide an answer using words, how long I'm having trouble understanding if you're expecting a paragraph or 3 paragraphs. Can you give me
Just
something?
a lot of these can be answered in just a sentence, and so
Okay, so
just a
not too
sentence,
long.
2 or 3 sentences is totally fine.
That sounds good.
Tyler, yeah.
Yeah, it says increase load from 1,000 MPa to.
Yeah, it's a typo, so it should be decrease the load to 2,500. So I know we did 10,000 here, so decrease it to 2,500.
Okay.
Yeah. Okay. All right, so that's problem 2. Problem 3 is just some short answer questions. So these are just conceptual questions, and so same thing for these. And so 2 or 3 sentences, however much you need to finish that. Yeah. Generally speaking, I have a lot of you guys to grade, and so the more efficient you are in writing your solutions, it's my policy is the easier it is on me. So as long as you can answer it completely in kind of the most efficient amount of words, that's good. Yeah.
Dr. Chan, you mentioned there's a typo in this document. Is that going to be a common pattern throughout the? Are there going to be documents throughout all the homeworks? Because I'm worried if there's an important typo. I'm used to following the instructions on the document, assuming the document has no typo. So if there's a typo, and I fall for that error, are you going to deduct points, or how is that going to work?
I mean, I don't try to. I mean, it's I don't try to make typos, but sometimes they occur.
If they occur, can you send us an email after class saying where the typo is specifically,
or can
you recorrect it?
Of course, yes.
Thank you, sir.
Yeah,
I'm just worried about following, not doing the assignment correctly because I followed the instructions bit by bit, and it wasn't my fault, though it was a mistake on your part.
Yeah, no, for sure. I mean, so generally speaking, when I grade these assignments, I don't look at just the answer. I follow your logic kind of all throughout. And so if I can see that, if I can see from your solution that you're following the process, and I can see your logic, but it may not match my solution because of the typo, I'm not going to mark you down for that at all.
Thank you, sir. So that try increasing the load, should we try decreasing the load?
So this should be
I just want to make sure.
Yeah, so
Thank you, sir.
what I'll do is I'll send an updated PDF tomorrow with the changes, and then I'll send an email to everyone just to let them know.
Thank you, sir. I greatly appreciate that. That would avoid confusions on both ends and
Yep.
make grading easier on your part.
For sure. Yeah. So I'll correct that tomorrow and I'll send an email.
Thank you, sir.
All right, so that's the activity. So you guys have about 15 more minutes today to work on it. Let me show you how to save before we go. Okay. And so to save your ANSYS projects, you actually need to go back to Workbench. And so Workbench is kind of the program that we kind of spent the least amount of time in because it's kind of like the master program that kind of launches everything else. Okay. And so to save it, if you're saving this on your local computer, so if you're working on your personal laptop right now, the easiest thing to do is just to save. Okay, so let me go ahead and show that to you. Okay. So let me save it to the desktop because I am considerate of the next person using this. Okay. And so I will just call this EGME 540 ANSYS activity 1. Okay, and so if you just click save on ANSYS Workbench, and if you go to the desktop, you can see here that it created a file here, okay, created called like a Workbench file. And so if you want to open up your project again, you would just double click on that file. Okay, so let me kind of demonstrate that. So let me go ahead and close everything in ANSYS here. Right, so I've saved it using just the default save within Workbench, and now I'm double clicking it again. It's going to take forever. Second. All right, and so now we have our project again. So if I launch mechanical again, you should see our results. Okay. All right. And so if you're working completely on your personal computer, I'd say that's the best way to save. I think it's the most convenient. Oh, question.
So we just attach the Workbench file and ignore the other two.
Right. So that's the tricky part. So if you're not working on your personal computer, so if you're working on one of the lab computers here, and you plan on transferring it home to work on it later, you actually need to save it a different way because when you click on just the default save, it not only creates this Workbench file, but it also creates a folder. So this folder actually contains your geometry and your simulation results. Okay? And the way ANSYS is designed, and I hate this part about ANSYS, is that it's very strict about the file pathing. And so even if you save this Workbench file and you save this folder and you save it to Dropbox or something you open up later, what ANSYS is going to complain about is that the file paths are not going to work out. And so the way to actually save it, if you're going to be working on the lab computers and transferring it between different computers, is you need to compress it. Okay. And so instead of just save, you're going to go to File on Workbench, and you're going to go to Archive right here. Okay. What that's going to do is that it's going to archive all of your settings, all of your simulation results, and all of the geometry into one file. Okay. So let's go ahead and click on Archive. And then it's going to ask you for a file name. So let me go ahead and just name it differently. File is zipped. Essentially what it's doing is that it's creating kind of a specialized zip folder of your simulation results. Let's save. It's going to ask you about all the archive options. Okay. And so it's going to ask if you want to archive the resultant solution, and you say yes. And all the imported files external to the project directory, let's say yes. In this case, we don't have any, but we can say yes for that anyway. Okay. You're going to click Archive. All right, and so if you do that, you should create this file right here. If you look at the file extension, it should be called WBPZ. The Z is for zip. Okay, and this is a zipped version of your file. Okay, so let me go ahead and close Workbench again, just to show you how to open it. Okay. To open up one of these zip files is a little bit different. So let's go ahead and open up just Workbench by itself.
I have a comment, sir.
Sure.
Would downloading, let's say I'm working on in the classroom computer and I downloaded my file as if it was on my laptop, but on the classroom computer, and I zipped it up and I emailed it to myself. Would it all still work?
Yep, that works.
Nice.
Yeah, that's kind of the useful thing about this archive, is that you can take this one file and then you can put on a zip, you can put on a flash drive, you can email it to yourself, you put it on Dropbox, and you can move it around between different computers. And,
yeah, just save it, zip it up, and email it to yourself, and you'll have it.
Exactly. Yeah. So that's one thing you can definitely do.
Sounds
But to
good.
open it, you have to open it in a special way. And so normally you would click on open to open up a project, but for an archive file, you would click on import. Okay? So you click on import, and then you're going to import the zip file that you created. Okay. That is new. So let me just try opening up just like this. Usually I click on import, but I think if you just double click, that should work too. I think ANSYS probably got confused because it thinks there's two projects that are open.
I guess my question is, instead of archiving, can we just do it the first way, zip those files up and then email it instead of archiving?
Unfortunately, that doesn't work because
Oh, it doesn't? Okay.
yeah, because you know what will happen is that it's the file paths, and so when you open up this this
Yeah, I'm talking about those two files, zip up and then just email it.
Yeah, unfortunately, that doesn't work because it looks for the files in a very specific location. If you kind of move the location of this folder, and like say that you do it on another computer, it's going to say that it can't find the files. Unfortunately, so the zip file is kind of the best way to do it.
Huh.
Yeah.
Sounds good.
Yeah, you can definitely try. I mean, this is kind of the activity to do it because there's I know
Yeah,
it took
I'm
us
sure
about
there's
an hour
multiple
today.
ways.
Yeah, because it took us about an hour today, but when you're doing this kind of on your own, you should be able to zip through it in about 5 minutes. And so
Sounds good.
you can try and see, but usually if I'm transporting this between computers, I do the archive version instead.
Sounds good. Thank you.
Question.
Thank you for that information.
Yep. Yeah. So if you want to go to your simulation, you would double click on model, and so that'll open up ANSYS Mechanical. If you want to modify your geometry, you would click on geometry. So we only did two programs today. So we did Design Modeler for the geometry, and then we did ANSYS Mechanical for the mesh and the boundary conditions in the simulation. Yeah. Okay. Thank you. Yep. Right, question? Yeah.
For the pressure, should we have made it a negative value?
Uh-huh.
The definition looks like it's compressed.
Exactly. Yeah. Yeah. So if you put a negative sign, that changes the direction to be just opposite of what it was. Yeah. Question. Okay, no problem. Yeah. Question. Oh yeah, yeah. I mean, you can do all the iterations within the same project. You don't have to create a different project for each one. And so let's take the first iteration first, right? So the iteration, you decrease the load to 2,500. So let's change this to, well, let's look at the results first. Okay? So we can see the deformation is about 16.8. Okay, and so we changed this pressure to 2,500. Solve again. You can see now our deformation is about 4.2. Oh, I see what you mean. Yeah, because with the positive, it goes in. So yeah, I had the sign conventions mixed up. Yeah. So if you want it to be a tensile load, you would have to make this a negative pressure. Yeah. But because we're using a linear model, the magnitude of the deformation is going to be the same. Yeah, it's just the directions. Yeah. Yeah. Good point. All right, question, yes.
I archived, but as soon as I downloaded and reopened.
Yes.
So if I'm doing this on my personal computer, do I need?
No, you should be able to just double click it on your personal computer. Yeah. All right, any final questions before we wrap it up for today? Okay, all right, so that's ANSYS activity 1. Let me stop the recording just so I don't get in trouble for this.